All right, section 6.5, complex numbers in polar form and De Moivre's theorem. De Moivre's theorem is the big one. That's if you're moving on to calculus, you want to see that. Remember, we're dealing with polar forms again, so a lot of the tools that we have from 6.3 and 6.4 are going to come back into play. Because we're looking at complex numbers, a plus bi form. Remember, that's um, the square root of an imaginary type scenario. So here we're looking at plotting complex numbers, finding the absolute value or the distance. This is distance, you guys. Write the complex number in polar form. Um, Convert complex numbers from polar form to rectangular form. So we got to go back. Find the product of complex numbers, quotient, uh, power of the complex numbers, and the roots of the complex numbers. So this is going to be a 3-day process. This will be the last day. This will be the second day. We're going to try and get through these today. I think those will be pretty straightforward. Um, just to finish up chapter 6 for um, the polar coordinates anyway. All right, so start with, they said plot this. So this is just a review of what you already know. If I were to plot these, remember this is your real, this is your imaginary um, axis. So 2 plus 3i goes over 2, up 3, that's A. B, negative 3, down 5, down here, that's B. C is going to be negative 4. That's going to be right there on the axis. And Z is negative I. Negative I is just going to be negative 1. That's D. So I think that's pretty straightforward. You guys remember that from chapter 1 or from first semester and from algebra 2 most likely. All right. Absolute value um, of a complex number. Now they call it the absolute value. They're going to continue to call it the absolute value. But you guys, this is just distance. Remember in the previous section we said r is equal to the square root of a squared or x squared plus y squared. Um, so this is the same thing. Square root of x squared plus y squared. Only now we've got a plus bi on the coordinate axis. So we're going to go my radius or my z, my absolute value, uh, is equal to the absolute value of a plus bi, which is just simply the square root of a squared plus b squared, and the I in this case is irrelevant. You kind of drop the I to calculate that. So I'm going to stop the video. I'm going to let you guys should stop the video, I should say, and let you guys work these out on your own. Okay, and to clarify this, remember, if we were to graph this, we know that if you would go right 5 and up 12, that would be up here someplace, right? Then the distance from the origin to Z is 13. And again, you guys can draw in that right triangle and visually see that. All right, polar form of a complex number um, is just simply taking this and putting this in the form of z equals r cosine alpha plus I sine alpha. Now the question is, well, how do you get alpha from this? Well, I'm glad you asked. Remember those tools that we had last unit? A equals r cosine theta, b equals r sine theta. We called it x, we called it y, right? But notice they're the same form, same formulas. Where r is the absolute value of z, okay? Um, or square root of a squared plus b squared. The other tool we're looking at here is inverse or is tangent. So in order to find the theta, theta is equal to the inverse tangent of b over a. And again, hopefully this makes some sense. This is just a revisit of what we've done, now only in a complex form. Okay. So we want to plot this, and you guys, I just sketched that. So we know where it's at, right? We know that this is going to be negative 1 down square root of 3i, right? Square root of 3 is going to be a little bit less than 4. So this is going to be down here. And if you want to draw the visual here, right? You got the r is also there. We need to write it in complex form, so we got to first find r. Square root of negative 1 squared plus negative root 3 squared equals square root of 1 plus 3 equals square root of 4, which we know is 4. Next, theta equals inverse tangent of negative root 3 over negative 1. Negative over negative is positive. That makes sense because tangents are positive in quadrant 3, right? So we know that this was probably a negative root 3 over 2 divided by negative 1/2. So the y value, right, is negative root 3 over 2. That means theta here in quadrant 3 was 4 pi, or is 4 pi over 3, or 240 degrees. Okay, so we now put this in polar form. Z is equal to R 2, and you guys, there was a mistake here. I could hear you guys screaming at me. Square root of 4 is 2, not 4. You're right, I'm wrong. 2 R cosine 4 pi over 3. And remember our formula said plus. So we're going plus sine 4 pi over 3, or 2 cosine 240 plus pi sine 240. Don't forget the I, which I did. All right, number 4 says write the polar form in rectangular form. Well, that means you've got to go back and you've got to figure out what your A and your B is, right? Well, we know A is equal to R cosine theta, and B is equal to R sine theta. So if we plug that in, we know R is 4 cosine 30 degrees. Cosine of 30 degrees is 4 times root 3 over 2, which is equal to, and I should have moved this stuff down a little bit, equal to 2 square root of 3. Over here, our sine theta is going to be 4 sine 30. Sine of 30 is 1/2. 4 times 1/2 is 2. Therefore, we have our rectangular form is going to be 2 square root 3 plus 2i. All right, products and quotients are what we're looking at. We're going to start with the product. The product of two polar forms, right, is just simply going to be z1 times z2, or the product of the radius, and we're going to add the thetas. Write it down so you know it. You don't have to memorize it, you just got to know it. Okay, so z1 times z2 is equal to 6 times 5 cosine 40 plus 20 plus I sine 40 plus 20, or 30 cosine 60 plus I sine 60. Not so bad, right? Division's basically the same thing. Notice that you're dividing and then you're subtracting. So the formulas are similar. Again, you need to write it down so that you have access to it. So if we're dividing, that's going to be z1 divided by z2 is equal to 50 divided by 5 cosine 4 pi over 3 minus pi over 3 plus I sine 4 pi over 3 minus pi over 3 equals 10 cosine 3 pi over 3, which is just pi, plus I sine pi.